Madam President, I rise today to speak about an amazing presentation I've had the privilege of witnessing twice now in the last several months at the University of Pennsylvania and at the medical center there. And I want to speak a little bit about the work that some scientists and doctors are doing that is extremely exciting and has great implications for all of us, really. But let me start with a little bit of background, some facts. In 2014, over 585,000 Americans died from cancer. There were over 1.6 million new cases diagnosed. And I think it's fair to say that every one of us has a family member, a very close friend. We know somebody closely who has been afflicted with some form of this terrible disease. The fact is, cancer is on the verge of overtaking heart disease as the leading cause of death in America. Now, we've made a lot of progress on many forms of cancer, but we still have a long way to go. But I want to speak today a little bit about a very exciting new therapy. Let's start with talking about cancer a little bit itself. The fact is, cancer cells have this protective shield, if you will. It's a shield that allows the cancer cell to hide from our immune system. If our immune system were able to function normally with respect to cancer cells, you wouldn't have cancer. The immune system would destroy the harmful cells, but that doesn't happen in cancer, and it's because of this protective shield. So can you imagine if we could develop a therapy that would penetrate that protective shield and allow our immune system to break through and destroy the cancer cells? Astonishingly, the very viruses that have been responsible for killing millions of people around the world, HIV, poliovirus, measles, they are now being used to create exactly this capability, this ability to break through cancer's protective shield. Researchers at the University of Pennsylvania, it's a team of researchers led by Dr. Carl June, have developed a process to harness the body's immune system to enable it to identify, track down, attack, and destroy an important form of leukemia, or blood cancer, that is most often found in children. In their trial, 90% of the patients with this relatively rare form of recurrent leukemia went into remission after they got this groundbreaking treatment, and their cancer has not returned. So Dr. June and his colleagues don't ever say this, but they may be on the verge of curing leukemia, and it's very, very exciting. So let me talk a little bit about the specific form of leukemia. Acute lymphoblastic leukemia is the most common cancer in children aged 1 through 7, young children. This is the most common form of cancer that afflicts them. There are 60,000 cases in the United States alone. Acute lymphoblastic leukemia, it's hard to say, so it goes by ALL. And it results when abnormal white blood cells accumulate in the bone marrow. The leukemia cells then are carried through the bloodstream to other organs and tissues, including the brain, liver, and other areas where they continue to grow and divide. Now, most ALL patients can be successfully treated with conventional chemotherapy, an expensive and sometimes dangerous bone marrow transplant, stem cell transplants. These therapies have improved enormously, and they work in most cases. I think about 80% of ALL cases can be cured with these conventional treatments. But the recurrent ALL, those who don't respond and are not cured by these conventional treatments, their prognosis is much, much worse. There's approximately 3,000 pediatric patients relapse after the bone marrow transplant procedures, and most of these relapses are early relapses, and candidly, they have a pretty dismal outcome. Only a 15 to 20% survival rate for children with these kinds of relapses. This is where this new therapy comes in. It's called chimeric antigen receptor, or CAR T-cell therapy. So what happens is doctors remove T cells from the patient, from the cancer patient. T cells are a type of white blood cell that we all have. It's part of our immune system. But then they take these T cells and they insert new genes from an inactive, harmless component of the HIV virus. They actually use part of the HIV virus to get into the T cells, which give the T cells a new capability. Specifically, they develop the capability to identify and link to a protein that is on the surface of the cancer cell. That's the shield that protects the cancer cell. And this enables the T cell in turn to then destroy that cancer cell. So that's the idea. The T cell is taken out. It's modified with the component of the HIV virus. It is then injected back into the patient where it multiplies massively and begins this wonderful search and destroy mission, searching for the cancer cells it's been programmed to find and killing them. Now, this treatment is specific to every individual patient. It works in part because it works with a patient's own T cell. And so that creates a whole set of protocols and challenges. You have to make sure that you're withdrawing a person's T cells. You go through almost a manufacturing process whereby you transform them so that they can be used for this purpose. One of the most exciting things about this therapy is that after a patient has been treated, after they've gotten their modified T cells put back into their body, and after the T cells have served their purpose, they don't just vanish. They remain in a person's system. They remain as part of the immune system, sort of on standby, ready and able to attack if the cancer would emerge. So they're still in the trial phase of this new process. Dr. June was, and his team, they were willing to take on the most difficult cases, and in fact, that's all they were allowed to take on initially. The first 30 patients that they tried this therapy on had already undergone chemotherapy several times, and the chemotherapy had failed. In fact, everything had failed for these patients. They had no treatment options left. By the time they got to Dr. Carl June and his team, these patients had weeks to live. In the first trial, 27 of the 30 patients were cancer-free 1 month later. 1 month after receiving the treatment, no cancer. 78% of the patients were alive 6 months after the treatment. And now 125 patients have received this personalized cellular therapy at the University of Pennsylvania for several kinds of leukemia. They have modified the treatment to address other forms of cancer, including non-Hodgkin's lymphoma, for instance. And more than 90% of the pediatric leukemia cases that they treated, the patients are still in remission. 4 out of 5 adults with non-Hodgkin's lymphoma have had complete remissions. This is amazing stuff. It's very, very exciting. Scientists across the country, medical researchers, doctors who are following this have been really blown away by the success, and they refer to it as a major breakthrough, as phenomenal. It's been what we've been hoping for, and just last year the FDA agreed that the progress is so stunning that they granted what they call breakthrough therapy designation for this therapy, for this treatment, because of the success they've shown in the early trials. This designation is going to allow Dr. June and his team to treat more patients more quickly who are in these very, very difficult circumstances. In fact, the University of Pennsylvania is now already working with Novartis to, in anticipation of the time when they'll be able to roll this out as a standard treatment, where it will one day, hopefully soon, no longer be considered experimental and no longer be the last resort for patients, but an early resort. The conventional treatments, chemotherapy and bone marrow transplant and stem cell treatments, they tend to have very unfortunate adverse side effects. It's been necessary because they can be successful, but one of the things that's wonderful about this therapy is that there are no lingering side effects. So it's enormously encouraging. It's very, very exciting. One of the things that's most exciting about this is that this technique, conceptually, could very well apply to any number of cancers, maybe all cancers. It's a matter, it's not a small matter, it's a challenge, but these guys are meeting this challenge, and the challenge is to design the transformation of the T cell in a way that will pierce that shield, that unique shield for each form of cancer, and they're making remarkable progress. They've also made tremendous progress on fighting multiple myeloma, another blood cancer that is very, very serious. I should point out, Dr. June and his team at the University of Pennsylvania are not alone in pursuing this general direction. MD Anderson in Texas is working to use the common cold virus, the virus that causes the common cold, to help fight brain tumors in a similar fashion. The Penn researchers, they have already developed a way to engineer immune cells in mice to fight a very dangerous form of brain cancer. And that's been so successful in the animal trials that this fall they will be able to begin human trials on this as well. This kind of brain cancer that they'll be trying to treat affects over 22,000 Americans. It's called glioblastoma, and people who are diagnosed with stage 4 glioblastoma have in very dire circumstances. The mean survival rate is less than 18 months. This is in fact the form of cancer that took the life of Senator Kennedy, who was a former colleague of so many of us. So this is just extremely exciting. 60 Minutes did a profile on some doctors at Duke University who are using a reformulated version of the polio virus. Instead of HIV, they're using the polio virus in a similar fashion, to enable our immune system to attack this brain cancer, glioblastoma. So I was frankly fascinated and incredibly excited about the progress these scientists, these doctors are making. But along the way, to get there, it costs money. And there's been a struggle for the funds to get this done. Dr. June's study has been supported by the NIH, by the Leukemia and Lymphoma Society's Specialized Center for Research grant program, a Stand Up to Cancer, St. Baldrick's Pediatric Dream Team, translational research grant. In 2008, the NCI had originally denied funding because they thought this was perhaps too risky. Fortunately, the Leukemia and Lymphoma Society and the Alliance for Cancer Gene Therapy stepped in. After they treated the first several patients, despite their success, they ran out of money, and they had to stop treating patients for over a year while additional funding was lined up. The fact is, this research that is funded by the NIH has given us tremendous strides in early detection and treatment methods and survival rates for a variety of cancers, but especially for this work. Now, I know that my colleagues and I are committed to continuing to fund the kind of research that makes these breakthroughs possible in a responsible way. I wanted to come down to the floor today and just talk about how important this is and how exciting this is. I personally think that we're in an extraordinarily exciting moment for healthcare, for our whole society. Technology is producing spectacular breakthroughs, and it seems to be happening on an accelerating basis. Some of the big, gigantic intellectual breakthroughs of recent years, the Human Genome Project, the gene sequencing, the technology that is available now that wasn't even imagined just a few years ago, the combination of these things is enabling us to make discoveries and breakthroughs and treatments that were beyond human imagination just a few years ago. And so I think we could be on the threshold of some absolutely stunning and wonderful developments. Personalized medicine is a big part of it. Understanding how our genes contribute to the healthcare problems we have, but also can be used to combat these problems. This is all readily, I think, within reach, and I'm just very, very excited about it. What I would just close, Madam President, is, I guess my message is, when you think about where we are, you think about how close we are to these stunning cures of some, amazingly devastating diseases. I think we should set our goal as curing these diseases. Our goal shouldn't be to figure out how do we treat this, how do we extend life for a few months. We'll do that for as long as we have to. But our goal should be a cure. Our goal should be to cure cancer. Our goal should be to cure heart disease. Our goal should be to cure Alzheimer's. We're going to be able to do this. And we should make that a goal. We should make this a priority. We have a lot of competing priorities for the limited resources that are available to the federal government. I can't think of any that are higher than this extremely noble effort, and I can't think of any reason not to. It is within reach. The progress is stunning and exciting, and it's happening all across America and very much in Pennsylvania. So I'm proud of the work that's being done in Pennsylvania, and I look forward to seeing it continue. With that, I yield the floor.